Morning, dear students. I welcome you all for one more class of chemistry. So, in the last class, I have introduced a theory called Dalton's atomic theory. Right? So, we just had an idea, right, about Dalton's atomic theory. So, a scientist called Dalton, he had just explained about the atom, or where the atom is present, and what is its structure and all, everything he has explained in this theory, right? According to what all the different views are there, according to him, he has explained about this, right? So as I said, there are five points here, or characters or postulates, one we can say. So the first point about Dalton is nothing but matter consists of indivisible atoms. So I have very detailed explained about this statement. I mean this about this character, right? So according to him, atom is the smallest particle. Indivisible means what? They cannot undergo into the further division. Why? Because they themselves having a single unit. So that's why the single unit cannot further undergo into the division. So according to him, matter is made up of with atom, and indirectly atoms are indivisible. That means one we can draw, or one we can learn from this sentence is atoms are indivisible means they cannot I mean they are very small particles, right? They are very small. That means they are, just because they are very small, they cannot undergo into the further division, right? So this is about the first point. And coming to the next point, atom of same element, very important. Atoms of same element, right? Same element has similar properties like shape, mass, and size, one we can say, right? So so this is very important character. One more, I mean, point. See here, just go through it. Atoms of same element, right? You take any element, I mean hydrogen, lithium, same element it should be. If I take as an example like lithium or sodium, whatever it may be, atoms of same element, what are the atoms present in the same element like sodium, right? Sodium is probably having atoms, definitely, just because of atoms are present in the sodium. So that's why it is one, we are saying that this is one particle or a matter, right? So now, what are the atoms present in the sodium, right? Small atoms present in the sodium, they must be, they must and should have same shape, right? Shapes should be same. If they are spherical, means the in the same element the other atom should not be what, cubic, right? That should be spherical. That means what are the atom belong to same element, they must and should have same shape, mass, as well as their size. If I'm of one family member, means our character should be same, right? So definitely some of the some or other character like color, or else one we can say the what, appearance, right? So that's why one we can say, if we see two brothers, then definitely one we can identify, they are brothers itself. Why? Because they are having some similarities, right? Similarities like it may be color, it may be what appearance, or it may be eye appearance, whatever it may be, right? There must be a similarity. As like that same character here, what he has explained is next point. Atoms belongs to same element. They must and should have, or they are having the same properties, similar properties, like their shape, mass as well as size should be same. This is second point of Dalton's, right? Understood? I hope you understood getting these points, right? So number third point is coming to the next point. Atoms of different element. This is just opposite of second point. Atoms of different element. Atoms of different element has different property, like has different properties like shape, mass and size. It's same property, but they are different, mass and size, one can say, right? So what I said, atoms of same element are having these three characters same, or properties are same. But if I consider one element as hydrogen and other element as scandium, right, then what happens is the atoms present in the hydrogens are different from what? The atoms present in the scandium, of course. Why? Because this family is different from this family. So thus they may be having the atoms present in the hydrogen, they may be having spherical shape, means they may be having cubic shape. Just for example, I am saying, right? If they are having mass like 1.66, then they may be having 1.5 or 1.8 or more than this. That means, or size, if they are having size like diameter like 10 raised to minus 3 means, they may be having 10 raised to minus 2. That means, they must and should, if the atoms belongs to different element, they are the atom present in them, they are having different characters like shape, mass as well as their size. But if they are belong to same element, then definitely these three characters must be same, right? So this is about what? Third point. Next is number 4. When atoms of different elements combines to form a compound, which is very common. So already we know what are compounds. For the formation of compound, we must and should have two different elements, right? Say for example, the atoms of, see here the meaning of this word, right? The atoms of different elements, whenever they combine, definitely there will be a formation of what? Compound, according to Dalton's. What he is saying that when atoms of different element, here there are two different elements, one is hydrogen and one is what? Cl. They are different, that means the atom present in these two may be different, as we saw here itself in the third point. And now whenever they combine, definitely there will be a formation of compound like this, right? Whenever the different atom of different element combines, definitely there will be a what? Formation of a compound, right? This is about fourth point. And finally, what he explained is, so once the compound or atom is formed, that neither be created nor be destroyed. And he has explained this point in different manner. Chemical reactions involve chemical reactions involve reorganization of atoms. Definitely, reorganization of atoms. Reorganization of atoms. These are neither be created. These are neither be created nor be destroyed. Sorry, nor be destroyed. A chemical in a chemical reaction. In a chemical reaction. So definitely in the chemical reaction, the rearrangement of atom takes place or the reorganization. That means the as I shown one reaction, definitely the atoms of H and Cl they reorganize. That means they combine, they overlap on one another, and there will be a formation of reaction. That means there will be a formation of product. Whatever the product may be, it may be a molecule, it may be a compound, whatever it may be. But what he is saying is these are neither be created, right? That means what are the overlapping is taking place from between two different atoms and all, those will not be created nor be destroyed in a chemical reaction, right? We cannot do anything with that, with those atoms. That means they definitely give the reaction, they definitely form a compound, they definitely form a different what molecules, but during that reaction we cannot create as atom and what we cannot reorganize it. It is a natural process, one we can say. That means these are neither be created. That means what all the reorganization of atom is taking place during the reaction, we cannot create those reorganization or we cannot destroy them. That means indirectly what we can say, atom can neither be created or nor be destroyed, one we can say, right? So dear student, this is all about the Dalton's atomic theory. Please you go through the book, try to make a notes, right? And check whether some or other point you will get new points. So add those points also. If you have any doubt, please do ask. And please, my one request is, I'm not getting assignments from all the students. I want more students to send the assignments. Why? Because what all I have explained during the last class, those type of question can solve a fourth class student also, right? So that much easy type of calculation is there. Why? Because I want you to learn how to convert Kelvin to Fahrenheit, Fahrenheit to degree Celsius, like, right? So that's why please go through it, try to send assignments, right? And most of you have sent the assignments. I'm happy, but all of you are not trying to send. You are not sending those assignments, right? I want you all to send the assignments. So this is all about today's class. During next class, we will go with the atomic number, mass number, and all, right. Thank you.